Greetings and welcome to my new calculus channel. My name is John Gabriel. So you'll know that in previous videos I talked quite a bit about the parallel concepts and how to teach your toddler the arithmetic operations and numerous other things. So I'd like to present a summary of all those things now and show you why they are so important. So first of all, um, in the article that I wrote, I gave you examples of how you can use blocks to teach your toddler the arithmetic operations. Okay, so, and also you can introduce the concept of parallelism by showing how that if this side is increased by its own length and this side by its own length, the line that joins these block trains, this golden line, will always be parallel. Okay, so it'll be parallel even to lines that are to block trains that are portions of it. So at this stage, a toddler wouldn't understand very much. So you might want to go to another uh, way to teach the toddler, and that's using a what I call a parallelometer, which I showed in the previous thing. And of course, if the lines here and here are the same distance, then it's parallel. Otherwise, it's not, okay? But a much simpler way, in my opinion, is just to have a line that swivels around a particular point and then just moving it up and down like this, showing that you can get to the original triangle, okay, or the smaller one. And then ultimately, you want to teach the parallelism concept. Excuse me. So, and the way to do that would be to show that any line different to this, to where the hand is pointing to this gold line, will not have the same area as you the same shaded area. So, if you, for example, for the blue block trains that you see down here, so let's see if I can. Okay, so for these blue block trains, if you try to do that, then this here would no longer represent the correct blue block trains because the area falls, there's a blank area here and this area falls on the top. And similarly, also with the red block train. Okay, so you basically explain to the toddler that the sides, the red and blue sides are in proportion and they're represented by what's called a ratio. It's just simply the red part to the blue part. Okay, and it uniquely identifies the ratio. And it doesn't matter what angle you use. Okay, you can use any angle you like, right? The story is exactly the same. Okay, so um, then of course the toddler as he gets older learns how to deal with ratios and he sees that what he learned earlier on is correct. Now, why are all these things so important? Okay, well, let's see why. Well, the parallel concept tells us that any line with a different slope will result in a different area, as I just showed you. So parallelism is important for all of the following reasons. One, without parallelism, we cannot properly define ratio or proportion in geometry or in any other way, by the way. In geometry or algebra or in statistics or any other way you like, you just don't have ratio without parallelism. Do you see how important it is? Okay. Then, without ratio, we have no valid way of deriving the most important concept of mathematics, that is number. Okay? Number is the number one concept in mathematics because mathematics is the abstract science of measure and number. Number three, without ratio and proportion, because from ratio we realize proportion. As I showed you, the sides, the red and blue sides are in proportion. Okay? And we have no way of realizing the arithmetic operations. Just imagine the arithmetic operations in algebra, not in geometry, in algebra. Okay, and by the way, those arithmetic operations were all established using geometry, symmetry of the circle, and ratio and proportion, which is what I've just been showing you now. So to sum it up, you just don't even have algebra at all, because if you don't have proportion, you don't have algebra. Okay, that's one of the things that allow you to manipulate an equation. It comes from proportion. Okay, and finally, we would never know how to work with fractions in algebra, right? So it's pretty serious. Therefore, we have to thank the brilliant Greek mathematician Thales for his theorem on parallelism and the knowledge that he imparted on parallelism. So this is the guy who started it all, okay, Thales. And what's written down here is gnothi se avton, which in English means know yourself. Okay, so this guy was absolutely brilliant. He realized the concept of parallelism, from which everything that followed in mathematics was based on. Okay, without parallelism, you don't have Pythagoras, you don't have anything. It's all built incrementally. By the time Euclid came along, he wasn't discovering anything, by the way. Euclid didn't discover anything. He merely recorded all the knowledge of the previous mathematicians. Okay, and Thales was one of the first. I think he was born around about 625 or 24 BC, long, long, long ago. Okay, and you can be very grateful to this person because without him, you'd have no technology, no chatbots, no computers, absolutely nothing. You'd still be roaming around like Neanderthals in caves and in the wilderness. So I don't think that most mathematics academics have even realized these things. But really, as the summary tells us, we wouldn't have mathematics without parallelism. And that's why you should teach your toddler as young as possible, even without numbers. You can teach your toddler that these things are in proportion, right? Because you use the block train method that I showed you in my article. Okay, so that plants a solid foundation for your toddler to become a brilliant mathematician. It doesn't need to be a knucklehead like you. Just kidding. Okay, so I hope you've enjoyed this little presentation. Uh, my name is John Gabriel, and before I sign off, if you're not already a subscriber, become one. Click like. I don't earn very much money. In fact, I haven't earned anything yet from any of my videos. I'll also place a link to a GoFundMe page where you can donate a few dollars if you want or if you're able. And I'll also place a link to academia.edu where I have a couple of, no, I have 3 free books, ebooks, three of which are free, and hundreds of articles that are better written than anything you find in the mainstream. There's nothing like them, by the way. And I'll also place a link to this applet that I've just been using to teach you these things, and you can download it and play with it and do whatever else you want. So, my name is John Gabriel, and this is a new calculus channel. Till next time, goodbye.